Hello to colleagues who are working with variant titanium ring applicator. In this presentation we will talk not only about new angular indicator for applicator reconstruction, but as well about applicator commissioning and compensation methods of so-called cable snaking effect. As you know, to create correct brachytherapy patient treatment plan, we need to identify the starting point of radiation source moving path, or position number 1, and accordingly all its dwell position in backstep way inside titanium applicator tube. So we have got box with a set of 3 titanium ring applicator with tandem angles 60, 45 and 30 degrees. Build-up acetal caps available here are 5 mm height black color, 7 mm height white color and 5 mm height black color with hole for needles. You know that on magnetic resonance images it is difficult to see the tip of applicator tube inside build-up cap, which is visible on MR images as a black cycle. For solving this problem, some authors recommend to use the ultrasound gel inside build-up cavity or thin plastic tube, diameter less than 2 mm, fill it with water, which has been inserted into applicator tube. But unfortunately, for our cases, this method does not work, maybe due to too large image step size or too high a noise level. For reliable detecting of applicator tube tip, it's needed dimensionally more extended landmark, and for this purpose we use 5 mm diameter plastic tube, fill it with water. To insert it into ring build-up cap, by milling cutter we do cylindrical groove perpendicular to the ring plane and or parallel to tandem tube, and as a result on the paraaxial MR images 5 mm diameter tube with water should be seen as good visible cycle on the acceptable range of slices. Firstly, into both sides of plastic tube should be inserted rubber stoppers. Secondly, the tube should be filled with sterile water using needle for let out the air and the syringe for water inlet. Finally, to be sure that this assembly is keeping together, the plastic tube and build-up cap are fixed by sterile tape. At the end we have got angular landmark with higher MR visibility and distinctness on images. Now all images of dwell source position should be coordinated relatively to this angular indicator with angle equal to 0. Film testing of radiation source dwell position is the next part of our presentation. Commissioning procedure. For fixation ring applicator tube, together with a piece of gophromic film, we use wooden block. Here you can see testing setup with afterloader. The shape of source guide tube we didn't keep under the control, as it happens in our clinical patient treatment conditions. Typical irradiation dwell time in each position is 7 to 9 seconds. Here is the exposed piece of film. Next step is scanning of a treated film using our Epson Expression 11000 XL scanner. The white lines on the film are the result of the mechanical outlining of applicator tube. We have special device for this. This is white-black BMP format of scanned film. For defining zero angular coordinate relatively to applicator tube, we use the center of cycle, which is delineated insidely or outsidely on applicator tube tip. Here you see demonstration of angular measurement of first dwell position, of the second dwell position, and so on. The source step size here is 1 centimeter. From fluoroscopic part of applicator commissioning, we measure relative angles between angular indicator and center of titanium tube tip. Here we name it as tube and cycle, which we use in film testing as a reference angle. This way we know angular positions of radiation source relatively to angular indicator, just what we need for applicator reconstruction in treatment planning procedure, or in table numerical representation. Source angular steps measured in different dates in different source guide catheter position are collected on this figure. The family of the curves reflects the accuracy level of the measurement and snaking nature of the source cable. Here is average film source angular steps curve. For the ring applicator taken from the brachyvision applicator library, we measure source angular steps curve by using singular method. In this case, angular zero coordinate we define at the center of the cycle, which is delineated insidely or outsidely on applicator tube tip. From this zero starting angle, we measure angular source position number 1, source angular position number 2, and so on. Here are results of two source angular steps measurement, which we combine into stylized library curve with equidistant angular steps. In this case, all steps are 35.9 degrees and the last one is 33.85 degrees. If we bring measured on film data, on this figure we will see that by shifting library curve up or down, it is not possible perfectly simulate or adjust library data to measured film results, because model library and real film measurement have different source angular steps. So for offset 0 centimeters, differences is in angular source position of library and film we compare on this graph. For most source position differences are more than tolerance level, 2 mm or 7 degrees, as mentioned in various technical documents guidelines. And that is why these source positions are need to be somehow corrected. Theory of that correction can be done by using so-called zigzag method. Zigzag or shortening source travel path between first and second source positions, with the effect when we keep the number 1 position on the same planes, but position from 2 to 10 are rotating clockwise for needed angular value. If we take offset 0.5 cm in attempt to avoid working in region of start snaking effect, the correction can be done by rotating clockwise all library source positions for required angular value to minimize difference with measured on film source positions. Now we are talking about correction of snaking effect. We don't discuss here correction of cable snaking described in variant guidelines number GM3 3 years ago, because this method do not clear for us. Next part of the presentation, methods of compensation the snaking effect. Version number 1. We name it as virtual shift. Always we are working with the offset is half centimeter. You see here library source position with offset 0.5 centimeter. Film measurement and library source position with shift. Calculated total error factor, green column, it is absolute value of difference between film and library with shift. Here we are looking for optimal shift to minimize total error factor, you see is 17.8. Optimal shift here is 13 degrees or 3.6 millimeters or approximately 4 millimeters. So in treatment planning, before we start optimizing source dwell times, we copy paste Ring Applicator and editing first point of source way by shifting it forward by 0.4 centimeters. Compensation method number 2 is zigzag. By this method we are shortening source way between first and second source positions. At the beginning of applicator reconstruction, we adjust 3 library source position number 1, 4 and 9 as close as possible to angular source positions as they were measured on film applicator commissioning. Similarly to previous method, we calculate total error factor, green column, for different lengths of zigzag. The minimum value for total error factor here is 19.8, or it is approximately the same order of value as was for previous method. And the last correction method we are discussing here is to construction such shape of source traveling path which give us perfect fit with all points in film angular measurement data. And in this case the total error factor will be 0. We transform point of library applicator by introducing 2 zigzag and moving away or closer to ring center points of source way. And here you can see the snaking result, where source traveling line remain its location inside applicator tube. As I told now, all source position precisely fit with measured on film source location, and we can in principle create the applicator template of such snaking shape and save it for the clinical using. But we think it is not practically necessary because snaking nature of the source cable do not predictable, and it dependent of source guide tube shape, and that is why we should use some average library model. And finally we discuss item about significance of snaking effect correction in clinical gynecological treatment plan. As an example, we take case with symmetrical high-risk CTV. Correction and dwell time optimization were done. DVH values are follows. Keeping the same source dwell times, then we return ring source position into its initial library location, and we have for DVH values. As you see, the effect of cable snaking correction in this case is quite low. And only if we take very asymmetric high-risk CTV very close to ring applicator, when even not necessary in loading tandem position, effect of carrying out snaking correction can reach approximately 20% for organ at risk. Finally, our conclusions. Angular indicator is very useful in clinical reconstruction procedure, and introducing correction for cable snaking effect is non-significant for most treatment plans.